But the next says, God, those dogs go off, don't they? I don't, I don't really hear them anymore. But when I listen to the playback, far out, it's like dogs. Now I can hear them because of, yeah, I was thinking about it earlier. They go off, don't they? Fucking cluster headaches. I suffer from cluster headaches. They've decided it's time to come on. So I'm gonna take the foot off the accelerator and put it in cruise. And what I'm gonna do, I'm gonna read through the book of popular science. And when I think there's something interesting, what I think is interesting about the science and the names that keep coming up, I'm going to read from the book. That way I don't have to bust my head because hopefully it won't get last year's were the mildest clusters I've ever had. So I'm hoping it's going to be mild. So we're going to go through those. But I'm not going to go looking through the index, the names. I'm going to read it from the beginning. This starts with the universe, like the study of the universe. It's all right, but we're going to start there. A couple of things, and I'll just go through it. There's no point. It's difficult to gauge the present right now to get a three-dimensional picture of it, unless you know what brought up the rear, what was being said. So it's 1961, right? That's 39, 50, yeah, a few years ago now, right? 60 something years. It's interesting. You'll see the names Galileo, Kepler, all of those names. They're stories. It's not real history. It's not. It's not real history. I'll show you what I mean. So I'll read in 15-minute stints. If I feel all right, I'll go maybe for half an hour, but we'll just keep it down to 15. This right here, my powerful magnets in there, and there's quite a powerful magnet there. It's on repel, so it's going to bounce away. I always think application, roulette tables in the casino, isn't it? You don't want the ball to land on a certain double zero. Somebody's just put 200 grand on double zero. Hit the switch. Doing. Yeah. So I decided to put that here, just for entertainment purposes only. And I'm going to read some snippets out of what was being said about everything back in 1961. Yeah, that's the headaches. I don't want to stress them. I want to start thinking about all the good stuff and be stressed about it. So, the study of the universe. It's going to be interesting tidbits. Sir Isaac Newton invented calculus to solve an astronomical problem. There's a thing, eh? One branch of mathematics, differential calculus, was invented by Sir Isaac Newton because he needed it to solve an astronomical problem. He was on the verge of announcing the all-important law of gravitation. He was comparing the fall of a body such as an apple near the Earth's surface with the motion of the moon around the Earth. To do this, he had to know how to measure the distance between the Earth and the moon, and between the apple and the Earth. Should he measure the distance between surfaces or the distance between centres? By considering the attraction of each little bit of the Earth for the moon or the apple and adding all these together, Newton found that the attraction in each case is as though the whole Earth was shrunk to or concentrated at its centre. From the knowledge obtained in these studies came Newton's invention of the fluxions, or differential calculus, Today, this branch of mathematics is one of the most useful tools at the disposal of the engineer. The successful prediction of eclipses has brought about new ways of measuring the size of the Earth and the distances between various points on its surface. By mathematical calculations, astronomers can determine when the eclipse will begin and end, as seen from various points on the Earth. By timing the actual beginning and ending of the eclipse as observed at these points and comparing them with the calculated times, we can check our previously accepted values. Now, this side man down as well. This thing, we can predict eclipses. No, you cannot. It's about previous observations that they presume something is going to happen in the future. If you took all the charts away from people and then looked like previous the history of it and said, right, predict the next solar eclipse, people would be like, I don't know. You need that first one. In fact, one's no good, nor is two. You need three of anything to start to find a pattern. Two's too random. You don't know which direction it's going in. The third one is when you start to get a sense of a pattern, direction. And that is the same with the eclipses. The more there are, they fall into patterns. Oh, that one was there that time, and then 18 years later, that is how. Without the knowledge of the past, no, they wouldn't be able to. So you can imagine how long it's taken for people to pass that knowledge down. But then again, you say that, right? It's another weird one. To pass that knowledge down, knowing that from one initial beginning of a Saros, a series of eclipses, 18 years passes before the second one of, look, it's that knowledge. But how? Right, so we've got that now. I go over. If you tell me that this has stopped spinning or doing things, I'll come over and sort it out for you. But somebody say something. Right. Now, I'm going to jump over. Where is it? Here. Now listen to this bit, right? Which is what I was saying. People say, no, we can predict eclipses. No, you can't. You're just following a pattern that is behind us, so you can make predictions about the future. Certain theoretical astrophysicists, as we call those who deal with the stars at advanced physical laboratories, study the observations and theories of the past and make predictions concerning the heavenly bodies. Most of the time, these predictions are fulfilled. When they are not, we usually know the reason why. Very often, a new physical principle is discovered because of the failure of a prediction to come true. So what that is saying is they don't know when the next solar eclipse. They wouldn't know. The only reason that they do know is because of patterns in the past. Like if you see a certain bus stopping a whole week, you're new somewhere and you see the number 3 stop at 10:15 every day, you know that probably if that happens for a week, on that Monday of the second week, that bus is going to be there at the same time. That is the pattern that they follow. That is how they know. Right. Yeah. So, the birth of the earth. He was a poet and he didn't know it. It's the birth of the earth. All right, here we go. It's just to get a sense of what it was like. because if you don't have that to look back at, this present moment doesn't really mean much, does it? Either way, where it's going or where it's been. If you don't know where it's come from, then you don't really. The early human inhabitants of this planet thought that the Earth was flat. It seemed to stand still with the sun, moon, and planets moving around it. The sky, as far as they could tell, was all above them. How could they have guessed that the Earth is a huge ball, rotating as it travels around the sun through the sky? How could they have guessed that the sky stretches in all directions away from the Earth, below it as well as above it? Of the universe and the Earth, early man knew only the tiny bit he saw around him near home. In the very early days, he had, of course, no means of travelling except on his own 2 feet. A man could live his whole life in a narrow valley, never guessing that anything lay beyond. His horizons were more narrow and limited than we can imagine. As time went on, legends and myths grew up about the Earth and the manner in which it is supported in space. Some early peoples believed that it floated on a great sea of water and that the sun, during the night, swam from the west to the east through that sea to get back to its rising place in the east. The early Egyptians thought that the universe consisted mainly of Egypt, was shaped like a shoebox. The sky was a metal ceiling through which the gods let down lamps at night, the stars, to make the sky more beautiful for man. The sun was a god who rode in a celestial boat around the ramparts of the world, disappearing at night behind the great mountains that rim the edge of the earth. Just brings me back to that time and date program, the way they had that moon going down behind the mountains. Huh. This is a night behind the great. At one period, the Hindus imagined the earth borne by a huge elephant which stood on the back of a gigantic tortoise, swimming in a sea of milk. A variation of this universe idea was that there were under the earth 4 foundations. The earth was upheld by 4 elephants supported on the back of the great tortoise. The tortoise himself rested upon a gigantic world serpent, coiled upon itself and floating on the cosmic waters. Huh. What supported the waters was always something of a mystery, however, and the subject of much discussion. In the days of ancient Greece, although most people still believed that the earth was flat and the center of the universe, there were a few scientists who were in advance of their time. They felt sure that the earth was round and that the stars were faraway heavenly bodies, perhaps like our sun. They had no way of proving this, of course, for the telescope was not invented until the beginning of the 17th century. Many of the ancients believed that the sun, the moon, and the planets with the stars beyond moved around the earth on great crystal spheres. The turning of those spheres was believed to produce beautiful, though inaudible celestial music. This music was called the new. Oops, settle. Where are we? This music was called the music of the spheres and was the conception of Pythagoras, a Greek scientist who was born in 580 BC. It's the way it's told. It's just a story, isn't it? It's a story. It's told like a story. The details. It is. It's a story. It's not real. This is not real. It's not. In the second century AD, there lived in Alexandria a great scientist, mathematician, astronomer, and geographer. His name was Claudius Ptolemaeus. He is usually known as Ptolemy. Ptolemy wrote a great book, the Almagest, from the Arabic word meaning great system, in which he gathered together the astronomical ideas of the early Greeks. He not only explained these ideas, but added some of his own. For many hundreds of years, Ptolemy's ideas about the solar system were accepted without question by scientists. He taught, as so many others had before him, that the Earth was the fixed center of the universe, around which all the other heavenly bodies revolved in circles. Ptolemy, however, observed that the planets did not appear to actually move as simply as that. To account for what he observed, that sometimes the planets seemed to move to the east and sometimes to the west, he invented a system of epicycles. If you will look at the diagram on this page, you will understand what epicycles are. Small circles, yeah. So basically, because when a planet skips over and we are on the opposite side of the sun, when they come back around, what is it? It comes towards us. That's only Mars and Venus. Venus and Mercury come towards us. They're in between us and the sun. So it looks like they're going east to west and then west to east. Boom, boom. They switch direction, but it's just them taking an inside berth. I'm sure that's what it is. Right, now, what I'm going to do... Oh, we've already gone over to 16. Right, now, let's see. Where were we? Was it... He taught that the Earth was fixed. No, where was I? Right. The Arabs were foremost in the study of astronomy in the Middle Ages. Here we go. About 1610, one of the most important scientific events of all time occurred. The story goes that the children of a spectacle maker in Holland were playing with some of their father's lenses one day. They discovered that by combining them in a certain way, they could make far objects appear to be close by. This discovery was the beginning of the telescope, which was very shortly to be used to such great advantage by the Italian astronomer Enter Galileo Galilei, known as Galileo. So the story goes that the children of a spectacle maker in Holland were playing with some of their father's lenses one day. They discovered that by combining them in a certain way, they could make faraway objects appear to be close by. So that their father was a spectacle maker, and he never looked through two of those lenses to see if there was a scratch on there, or... This is where it begins. This is where it begins, right? That didn't happen with the Dutch children and the lenses. If you have to think about these things. Guy was he made glasses, for crying out loud. Back in those days, I don't know. Lenses. He wouldn't have... His kids. Oh, Dad, look. Oh, I've been working with these for 20 years and didn't realise this is where it starts. I'm telling you, it's ridiculous. All right, where were we? No. Now I am... I am going to pause right now. Hang on. And we are back up and running. Right. Since the beginning of the 19th century, many theories have been suggested to account not only for the birth of the Earth, but for the birth of the whole solar system as well. For of one thing we are certain, with the Earth were born the other members of the Sun's family. With the Earth were born the other members of the Sun's family. Remember, 1961. This is what was said, what was thought about everything. Not only those people who knew nothing whatever about science, but most of the astronomers also, before the time of Nicholas Copernicus, believed that the Earth was the center of the universe. It stood still in the sky, so they thought, while the other heavenly bodies moved around it. Copernicus, a Polish monk, was sure that this idea of the solar system and of the universe was wrong. He believed that the sun was the center of the solar system and that the planets, the children of the sun, moved around it in orderly paths called orbits. Copernicus wrote a long and very important book in Latin, giving his reasons and such proofs as he could muster for this belief. While there were some astronomers who agreed with Copernicus, it was a long time before his theory was generally accepted. It was a religious conviction with many people that God had created the earth as the center of all that existed in the universe. To deny this was to them a dreadful heresy. In time, however, Copernicus's ideas about the sun and its family came to be accepted under the name of the Copernican system. See, we've heard of it, but there's a lot of things that we've heard of that don't seem to be. The work of Galileo did a great deal to prove that Copernicus had the right idea about the solar system. With his telescope, Galileo discovered, for one thing, that the planet Venus passes through phases just as Copernicus had predicted. Galileo discovered also that there were four large moons moving around the planet Jupiter. His telescope was not powerful enough to show any of the other seven Jovian moons. Seven. What is there? There's over 100 now, isn't there? So back in 1961, they only thought there were 11 moons around Jupiter. Unbelievable. His telescope was not powerful enough to show any of the other seven Jovian moons. This proved that there were at least some heavenly bodies that did not move around the Earth as their center. Galileo's discoveries were, of course, the first stepping stones towards actual proof that all the planets move around the Sun instead of around the Earth. Even after Galileo's observations had proved that the Earth is not the center of the universe, people were most unwilling to give up their old ideas. In fact, Galileo was convicted of heresy by the Inquisition and sentenced to prison, though the sentence was never carried out. He was forced to remain in seclusion for the rest of his life, however. In time, Copernicus's work was proved to be correct in its main points, largely through the work of the German astronomer Johannes Kepler, is Kepi. Basing his theories on data collected by Tycho Brahe, a Danish astronomer, Kepler formulated three laws of planetary motion. One of them states that the planets do move around the sun. See, this right here, these names, something is out. Sir Isaac Newton, one of the greatest scientists of all time, followed the teachings of Kepler and discovered why the heavenly bodies do not fall from their places, but through countless centuries have kept to their paths in the sky. Don't forget 1961. This is where? Look, this must be ground zero-ish for where this stuff started to come out in encyclopedias. About 1955, there's mention of Roma and Fitzo, but also that Roma was observing Saturn's moons. All right, here we go. Sir Isaac. Sir Isaac was the first scientist to explain that every particle of matter in the universe exerts a pull upon every other particle of matter. He called this force gravitation. Here we are, ground zero. The gravitational pull of the Earth holds the moon in the path that it travels around our planet. The gravitational pull of the moon upon the Earth, on the other hand, causes the tides to rise in the oceans of the Earth. And just so the gravitational pull of the sun holds the planets in their paths and keeps them from flying off into space. The laws of planetary motion and gravitation still hold true. In the years that have passed, astronomers have constantly made new discoveries about the various members of the solar system. They have never found any evidence, however, to contradict the results of the superb work done by those two scientific geniuses, Kepler and Newton, who set down the laws of planetary motion and the laws of gravitation. Those two boys had it nailed between them, didn't they? Can you not see how perfect it is? A couple of them passing the baton to each other. Oh, I give you gravitation. Oh, I give you the laws of motion. Every action has an equal and opposite reaction. I do like the one that, this one, his first law, that will stay like that until somebody touches it or until whatever. It will just stay like that. That's his first law, his first Mickey Mouse law, honestly. The absurdities, right? Shall I turn that? Let me turn that magnet over. The magnet's inside over. It might be a bit more exciting. I'll pause you. All right. Okay. Well, I'll read that. Sir Isaac was the first scientist to explain that every particle of matter in the universe exerts a. Oh, hang on. Like that. No. The laws of planetary motion and gravitation still hold true. In the years that have passed, astronomers have constantly made new discoveries about the various members of the solar system. Hang on, with that. It was not until all the groundwork done by Copernicus, Galileo, Kepler, Newton, and many others was finished that astronomers could begin to work out intelligent theories about the birth of the Earth and the origin of the solar system. It was not until the groundwork done by Copernicus. It, it just all sounds like it's brand new. It, 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 it sounds like it's just like a play, like a. It doesn't sound something that's happened gradually. All of a sudden, everything is in place. It's something is weird. It just is. Any theory to be at all satisfactory must conform to the known laws of how planets behave. Certain similarities in the behavior of the planets are very striking. See, they're actually telling you right there any theory to be at all satisfactory must conform to the known laws of how the planets behave. Let us examine some of these likenesses, for they must all be taken into account in the making of a theory about the planets. There you go. So, any theory that comes up about the planets that doesn't include gravity don't count. Number one, all of the planets move in the same direction around the sun. Number two, they move in very nearly the same plane. To understand just what this means, let us compare a merry-go-round and a roller coaster. In the merry-go-round, the horses all move around the center on one level or in one plane. On the roller coaster, the tracks go up and down and the cars that travel on them do not travel in just one plane. A line drawn between any two or more points on a plane surface will lie entirely within that surface. If the tracks of the roller coaster were all laid out on a flat surface, but of course it would then no longer be a roller coaster in brackets, the cars would travel in one plane. Number three, the planets move in very nearly circular paths around the sun. In actual fact, these paths are slightly elliptical or oval, but not very far removed from the circular form. See, 1961. Number four, the solar system forms a little family by itself in space, since its members are somewhat clustered together. Number 5. The sun spins or rotates on its axis in the same direction as that in which the planets revolve around it. The planets too rotate in the same direction as that in which they revolve. Most of the 30 moons in the solar system far out. In 1961, they only knew of 30 moons in the solar system. Although not all of them travel around their primaries, the planets to which they belong, in that same direction also. The planets are located at more or less regular distances from each other. Well, no, they're not, sir. Well, I suppose for Mars and then that massive jump to Jupiter. Each planet, number 8, each planet with its own moons forms a kind of miniature solar system that bears some resemblance to the solar system of which the planets themselves are a part. Scientists believe that because the planets behave alike in so many respects, they all have been formed more or less at the same time and in the same manner. After all, if the various planets were formed at different times and in different ways, we should not expect them to behave so much alike or to follow an orderly pattern as they do. All right. Therefore, any theory about the birth of the Earth takes the common origin of the planets for granted. After examining the facts about the planets and keeping in mind the orderly arrangement and working of the solar system as a whole, the astronomer is ready to work out his own theory as to the origin of the solar system and of Earth itself. All right, well, I might call that for now. So I'll read, and then when I spot interesting bits, I'll make a note, and then that gives me time to chill, let this head fucking take it easy. All right, folks, buenas. No, and I will go through some comments because I will, it's going to take it easy just for a week or so till the meds kick in properly, and then I'm going to rip it up again. All right, peeps, laters.